All right, so for this part of the class, we are going to be working on some word problems. All right, we're going to work on some word problems and we're going to change these word problems into equations and then solve them. All right, the goal is to learn how to solve the equations, but also how do we connect and relate this to real life so that when we get situations, we can put it in an equation form and we can solve them. So the first one we're going to look at. Let me see if it will paste. Bam, there it is. It says after paying $6 for a pie, or the pie, so you go to the store and you pay $6 for the pie. Sally has $51 left. How much money did she have before buying the pie? And we could always work this out like regularly in our head. But we need to look at it and write it in equation form. When I say equation form, we need to have an unknown variable. So this unknown variable is trying to figure out how much she had before buying the pie. So whenever they're asking a question, that is the unknown variable. We need to identify which part of the question is the unknown part. And normally the unknown part is what they're asking. So how much money did she have before buying the pie? And that's the unknown part. So you know what? We're going to call that X. We're going to call that X. All right. And then it said that she paid $6 for the pie. All right. So we're going to subtract $6 because it said how much money did she have before. So she went with X amount of dollars and then she paid $6 for the pie. So I'm going to take out that $6. And then that is equal to 51. Because when you, however much money she had, you're going to minus the 6, because it's $6 for the pie. And then that's going to equal to how much she has left. She has $51 left. Now we go into solving this equation. All right. So when we look at this equation, we could say this right here is plus 6, because I'm trying to find X. So X is equal to 57. So we could say she started and went to the store with $57. She went to the store with $57. And then now we could say this is one solution. This equation has one solution because it's X equal to 57. All right, that's how we're going to turn a word problem into an equation and then solve for it. All right. So the next question we're going to look at is this one. It says Dan has 36 books in his library. He bought several books at a yard sale over the weekend. He now has 65 books in his library. How many books did he buy at the yard sale? We could already look at this and know how many books he bought. This is not hard. But the goal is to try and turn this into an equation. So again, we got to figure out the unknown variable. And the unknown variable is what they're asking normally. All right, the unknown variable is what they're asking for. So we're going to go ahead and write or X, or we could use Y or Z. And we're going to say the X is how many books he bought at the yard sale. The X is how many books he bought at the yard sale. So we always identify our variable as what they're asking for. All right. So Dan has 36 books in his library, right? So he started out with 36 books. And then he went to the yard sale and bought X amount of books. And now he has 65 books. That's all it's saying. And X represents how much he bought at the yard sale right here. Now I need to solve this equation. And I'm going to solve it like how we normally do. So since it's a positive 36, I'm going to minus 36. And whatever you do on one side, sure enough, you got to do it on the other side. So x, and this right here is 0. X is equal to 29. And with this question, is it one solution, no solution, or infinitely many solutions? I want you to put it in the chat, and then I'll see it, and let me know. Is this one solution, no solution, or infinitely many solutions? We got an answer in the chat. One solution. It's one solution. Because it says x equal to a definite number. So it's 1. Oh, that's not how you spell solution. Here it is. One solution. One. One solution. One solution. All right. So I'm going to go ahead and I'm going to pause. All right. We're going to step it up a notch. All right. We were down here. We need to get up here. Okay. So we're going to put in this next question. Oceanside Bike Rental Shop, that's just a regular store, and they rent bicycles to people, all right? Oceanside Bike Rental Shop charges $15 plus $9 an hour for renting a bike. So if you're going to the store to rent a bike, they're gonna try to charge you $9 for every hour that you have it, and then they're gonna add $15 to it. That's what this is saying, $15 plus $9 an hour for renting a bike. All right, Sandy paid $78 to rent a bike. So after they charged her the $9 an hour and then they added the $15 to it, her total came out to $78. How many hours did she pay to have the bike checked out? So already we know whenever we're trying to figure out what the variable is gonna be, we go ahead, let's write our x. I like using x. Go ahead, use your y, use your z, use your m. It doesn't matter. It's a variable. All right. So it says how many hours. So we know that our variable represents how many hours she has to pay. How many hours did she have the bike? That's what our variable represents. Now I need to put in the other numbers. All right. She paid $78 total. So I know that her total is going to equal to $78. So I'm going to go ahead and put that in. Her total equals 78. They said it, not me. All right. And it says $9 an hour. If I'm going to do $9 an hour, I have to do 9 times x. Because it's 9 times however many hours. For example, what's a good example? If I say I go to what do people be doing? You know, like when you're having a birthday party and you have to rent tables, and they might say you could rent the table for $2 an hour. So for every hour you have that table, you have to times it by 2. So if I had the table for 1 hour, that's $2. If I have it for 2 hours, that's 4 hours. If I have it for 3 hours, that's 6 hours. That's $6. All right, so with this, I have it for X amount of hours and I have to multiply it by 9 because that's the hourly rate. Similar when people work and they make $12 an hour, for every hour they work, they get $12. For every hour you have the bike, you have to pay $9. So with this, it's 9 times X, and then we have to plus, because it says they charge $9 an hour, but then they put on an extra $15. What? They put on an extra $15. So now I have to solve this question. We do the regular additive inverse, minus 15. So I have 9x, this is 0, right? So I have 9x equals to 78 minus 15, which is 63. And then we have to do the multiplicative inverse. Let's get a different color. So x is equal to 7. And with this equation, like the other ones we were working out, it's one solution. Cool. Let us work out one more printing. All right, so we're gonna look at another problem. I'm gonna put it in right here. There it is. Cool. On Monday, 184 students went on a trip to the zoo. Shoot. The zoo is fun now. 184 students went to a trip to the zoo. All 4 buses, so they had 4 buses. All 4 buses were filled. And 4 students had to travel in cars. So 4 students went separately. How many students were in each bus? So I'm going to write my variable. You know what? Let me use a different one this time. I'm going to use a different one this time. So I'm going to say, wait, switch. I'm going to say y. My variable is y. But my variable represents what they're asking. So I know y represents how many students were in the bus. All right? And it told me, I'm going to go ahead and put my equal sign because the total was 184 students. Right? But it said there were 4 buses, and then it's asking me how many students were in the bus. So then I know it's 4 times how many students. The amount of buses times how many students. But there was an extra 4 students that went separately in a car. All right? So it's saying for 4 buses, I need to figure out how many students are in it, plus the extra 4 students that's equal to the total amount of students that's in the car. It's 100 in the trip, which is 184 students. So we work this out like normal. We do the additive inverse first. So we subtract 4 on both sides. I'm gonna let you write that. Which leaves us, this is 0. This right here is 180. And we're left with 4y. Right? The next part is the multiplicative inverse. So we divide by 4. So y is equal to 45. When you do the division, it will equal out to 45. And like the other ones, all these questions that we've done so far, they have one solution because they're all x equals a. A representing, in this case, it's y equals a because it's a y value. And then a representing the 45. Sweet. If you have any questions about this, feel free to reach out to me, email me, anything that you feel necessary. But these questions are fun, all right? Keep practicing them.